So question 3 is standard sort of exam question where you've got some unknowns in the probabilities. And the first thing you could do is, well, when you add up all these probabilities, you know the total is going to equal 1. So we've got 2p plus q plus 0.5 equals 1. So the first part of this would be that those two bits are going to add up to 0.5. And usually we're going to set up a simultaneous equation for this. The second piece of information we're told is that the expected value of x is 0.4. So if we times these things together, that's 0.1, isn't it? 1.5 times 0.3, that's 0.45 and 2p. And when we add up all of that, the total should be 0.4 because we were told the expected value of x was 0.4. Interestingly, on this one, yeah, the p's actually cancel out, don't they? So we've just got 0.55 minus q equals 0.4. So actually, it's quite an easy one that q equals 0.15. So once we know that q equals 0.15, we can put that into there. So 0.5 take away 1.5, divide by 2 gives us 0.175. So usually that's a simultaneous equation you've got to do. You're lucky that that one wasn't. Now we've then got to go on and find the expected value of x. So let's do that. You've then got to find the variance of x. Let's remind you how to do that on the calculator if you want to see that again. So through my x values here, I'm putting -2, -1. This one's a half, 1.5 and 2. And my probabilities here were p, so that was 0.175. Q, which was 0.15. We already had the 0.2 there. We already had the 0.3 there. And the last one was another p, 1.75. So I put the data into there. And I'm then going to do the calculations, the one variable calculations. And yeah, look, here it tells me that the mean is 0.4. Brilliant, that's what I wanted it to be. It tells me that my standard deviation is 1.4543. And so I'm going to go back into here. 1.4543 squared tells me that my expected value of x squared was going to be 2.11. Sorry, I lied. Not my expected value of x squared is going to be that. My variance is going to be that. Yeah, well, I mean, I was thinking of x squared because the next thing I wanted to show you was that if we go in here and we don't want to rely on just that, then of course we could just take our expected value of x squared value, which says here is 2.275, and then we can do the usual thing, 2.275 minus the 0.4 squared, and we can get this in the same way that way. So 2.275 take away 0.4 squared, and this time we get it a bit more accurately, 2.115, but similar to what we had before. I'll pause there. I think I'm going to rub out these bits here. So the last section of this says find out the expected value of 1 over that bit there. Now, unlike the expected value of 2x add 1 or 3x take away 1, it's not a linear combination. For this one here, we actually do have to find out all of the new values here. We can't take any shortcuts here. So r is 1 over minus 2. Sorry, missed off the top. So we've got minus a half here. 1 over that is minus 1. 1 over a half is 2. 1 over that is 2/3. And 1 over that is a half. The probabilities, though, they don't change. So this is the 0.175. This is the 0.15. Here's the 0.2. Here's the 0.3. And here's the 0.175. And now we want to find the x times its probability. So work out all of those and add it up, and you'll get your answer. Now, the bonus for staying with me for this long is that I can show you how to do this really quickly on the calculator. We already had those numbers in the statistics calculator there, so watch this really clever bit here. In list 1, what I'm going to do is I'm going to type 1 divided by list 1. And what's happened is all of my little, I put one take away, didn't I? Whoops, so I'll try that again, sorry about that. So in this list, in the column title there, you take what you want to do. So I want to do 1 divided by list 1. And magically, all of my numbers here have changed to these numbers here I've got in the table. Now I can just go for the normal thing I did before, and it tells me my expected value of X here is 0.45. So there was a reason for watching for 5.5 minutes.